Hello. I was just at a session up north where I was showing people some various exercises for hand movements. And our groups use hand movements in some of our Parkinson's groups with table tennis. And I had prepared this brief little lecture. So that's why I'm sort of up here, all sort of pedantic, giving a little mini lecture. But I thought that you might be interested in some of this information. Um, from functional magnetic resonance imaging, that's a fancy word for scanning, brain scanning studies. Um, we know that there's widespread activation from finger movements, sort of repetitive finger movements like this or tapping movements. And you can see here in this image that there's quite a lot of activation going on in various areas of the cortex. And it's also the case that if a person's fingers are just massaged, so if you do these massages, and we do that in our warm-up routine, you'll see there's another video on the warm-up routine which shows this. You also get widespread activation with just the finger massage. And down here, this structure here is the cerebellum. It's this cabbage-like structure in the back of the head. And it's interesting because if we look at just that structure alone, we find that similar is the case, that with lots of, with various hand movements and finger movements, you get quite a lot of cerebellar activity. And there's also widespread cerebellar activity just with massaging the fingers. And of course, the cerebellum is also tightly linked to the cortex, which is these other areas that I've shown you here. So let's see if I can advance the slide to a slightly different view. These are just artistic images, sort of AI images, because I thought they looked kind of nice, but they can serve the purpose here. The cerebellum is, now I'm looking from just at the bottom of the brain. You can see the cerebellum is down here. It's quite interesting because the cerebellum actually houses more than 50% of the neurons in the brain, and some estimates are even higher. There's some research suggesting that it's closer to 70 or 80%. So the cerebellum, it's a highly adaptive and very evolved structure in our brains, and the cerebellum is generally known for coordination and movement. But it plays a very, very big role because it's also involved in attention. It's also involved in thought processes. And here, with more than 50% of its neurons, and it's a structure that only occupies like less than 10% of the total brain volume. And what I wanted to emphasize, though, is that if one motor system of the brain isn't working properly, it doesn't even have to be a motor system. If one system of the brain isn't working properly, the brain often relies more heavily on another one. So we call this compensation. For example, with Parkinson's, it primarily affects the basal ganglia circuits, but cerebellar networks, they often play a role in movement control, and they very often play a role in compensation, where they're doing a little bit more of the work and they're compensating for another area. They're also highly connected to the cortex. So here's another AI generated image, a pretty one, I think. It's kind of icy looking, but you can see here the cerebellum down here at the back and lower part of the brain here, where the cortex is up here. And the cerebellum is actually talking to areas of the brain like the premotor cortex, and they are heavily linked. So there's high a number of connections that are going on. They interact together. So whereas we know that there's exercises for balance and core, and we do this in our exercise programs prior to playing table tennis, for example, and there's a video on our exercise routine if you want to look back from a few weeks ago or even months ago. We have exercises for balance and core. Those utilize the cerebellum. Coordination training utilizes the cerebellum. Hand and finger exercises and rhythm, like repetitive movements, they all engage the cerebellum. And the cerebellum doesn't work alone. Like I said before, it's strongly connected to frontal networks that are involved in attention, in planning movements, and in thinking, or the fancy word for it, cognition. So exercise, exercise, exercise is far more than movement. And here's just a small schematic of some exercises that one can do with just the hands alone. You can do this any time of day. You can do this at home at night when you're resting and relaxing. We've got some here that are just hand and finger massages, like here, literally massaging the palm of the hand, massaging the knuckles, massaging the finger, not real hard, but just giving them a good rub. Finger stretching as well. And we do these in our warm-ups when we have our table tennis, but you can see they're readily accessible kind of exercises that we can be doing every single day and even more than once a day. Don't overdo. Don't overdo anything, everything in moderation. But we can do these. We have fist clenching. We also do some wrist and fist extensions, and then those standard kind of tasks like a neurologist would do, thumb opposition tasks like this, and then sequential tasks where you do one finger and then the other one against the thumb, and then attempt to go faster and faster and faster. So those kind of exercises are generating quite a lot of input to the brain. The brain is receiving the sensory input, and also the brain is sending motor signals to the hands. And I think we should just remember that, if one system isn't working so well, the brain's really clever, the brain's really adaptive. We keep exercising the brain continues to compensate, and well, who knows its limits, really?